Everybody brought their cell phones again? That should be a given, right? All right, so I'll give everybody a second to find where we left off. If you don't remember, we stopped at pyridoxine or vitamin B6. So with pyridoxine, U.S. intakes are usually generally above the RDA with an upper limit of 100 milligrams per day. However, deficiency or overconsumption of this, interestingly enough, can produce the same consequence or side effect, which is permanent nerve damage. So not a very fun consequence of not getting enough or even eating too much pyridoxine. You get some, but very minimal storage in the muscle. It's not really. It's very transient, not very high quantities. But the main function of pyridoxine is to act as a coenzyme, as many of these vitamins, as we discussed last week, do, is a coenzyme or a cofactor in various functions of metabolism. So it functions as an enzyme or a coenzyme PLP, which is involved in amino acid metabolism, and also glycogenolysis, or the breakdown of stored glucose, right? Glucose gets stored in the body as glycogen, and so it functions as a coenzyme in such a capacity of breaking down glycogen to provide your body glucose in times of need. It functions as a synthesis of a number of compounds, one being heme, which is essential for iron and iron transport. So you can imagine that if you don't have enough pyridoxine, you could also become somewhat anemic because you aren't producing enough heme. Neurotransmitters, hence its involvement in neurologic function, and also the synthesis of other vitamins. It has some function in supporting the immune system, and although deficiencies are rare, it can cause a rare form of anemia, as I mentioned, because you are not supporting heme, which is necessary for carrying oxygen in red blood cells. So, as a pharmacologic use, high doses of pyridoxine can be used to treat carpal tunnel syndrome. And if not, I'm guessing many of you probably aren't. You've probably heard the term carpal tunnel syndrome. But from an interesting standpoint, and something that I dealt with quite regularly as a chiropractor in my clinical practice. So your hand has small bones in it, the first few rows, and those are called carpals. And at the base of your hand here, in the base of your palm, there's a piece of connective tissue that goes from here, right underneath your thumb, all the way across to just underneath your pinky. It's a piece of fascia, and it holds your hand together, so it gives it a nice cup shape and gives it some form and function. And it creates a tunnel underneath because you have nerves that run from the base of your neck, nerve roots that run from the base of your neck and the top of the upper part of your mid-back that run and give motor and sensory function to your arm and hand. And those run through this tunnel, hence being carpals and there being a tunnel called the carpal tunnel. And so people that work at desks often lay their hands flat, or people that work on computers, students being included in that category. If you lay your hands flat, you can stretch that tissue out and essentially decrease the amount of space that the nerves have to travel through that tunnel. And that can cause inflammation and irritation, and it can become very painful, and so you get numbness and tingling in your hands. But carpal tunnel is actually one of the most overdiagnosed conditions from a musculoskeletal injury standpoint, because as I just mentioned, the nerve roots in your neck and upper back control the motor and sensory function that travels down into your arm. And one of the other consequences of sitting and being a student or somebody that works at a desk all day long and typing and looking down or texting on your phone is that it decreases the mobility and the natural form and function in the within your spine, and that can compress those nerves at the source of their nerve roots, causing similar symptoms. And so a very simple way to tell if somebody has carpal tunnel, if they tell you, well, I have carpal tunnel, is to take their hands and push right where I showed you at the base of the palm. And if that doesn't make them jump out of their seat, they don't have carpal tunnel. But they still can have nerve deficit. And so pyridoxine, from a pharmacologic use standpoint, has been beneficial in supporting some of those neurotransmitter functions that can overcome some of these deficiencies caused by nerve irritation. It's been used for treatment of symptoms of PMS, but there's no real significant benefit, and it's mostly anecdotal evidence that supports this, so I don't really have an answer for you as to why, just that it has some application in there. And then it can also function for nausea during pregnancy. Again, I'm not entirely certain why that may be, but there is some anecdotal evidence and some limited research that supports it being used for nausea. However, I think it is important to just draw back again and get your guys' clinical brains thinking, since so many of you have an interest in a clinical path, that while pyridoxine can be used to treat nerve deficiencies, as I mentioned, overconsumption of this can also cause essentially hyperactivity within that neurotransmitter function, and that can lead to some neurologic dysfunction as well. And so that may not be something that's super beneficial. And so while it would be, being as that this is a water-soluble vitamin, it doesn't have much storage within your body, it's going to be quite hard to overdose somebody on pyridoxine. It is possible, so you need to be very careful. Again, when we're talking about clinical treatment and use and saying that these things have pharmacologic benefit, that means that these have usually super physiologic doses, because your body can only metabolize so much at one given time, right? So you might need to have like multiple doses throughout a day, and they're going to be incredibly high to make sure that your body is taking in as much as possible, right? So just things to keep in mind. Folate, or vitamin B9. This is a really important water-soluble vitamin. It's one that gets quite a bit of attention for very good reason. So folate is usually analyzed as dietary folate equivalents, or DFEs. It accounts for the differences in the absorption of folate versus the natural and synthetic sources. Okay, the upper limit of consumption is 1 milligram per day. Concern with synthetic sources and that taking in too much folate or folic acid can mask a vitamin B12 deficiency. That comes through some biochemical interactions that are not necessarily important for you guys to know about at this point in your academic careers, but just note that folate in high doses could mask that deficiency. And so there's, again, this give and take of having an adequate amount of intake and not being deficient in something, but not over-consuming something, because overconsumption doesn't necessarily mean beneficial just because it's a quote unquote vitamin. Because of its importance in nutrition and metabolism and just general function, it's fortified or added back to just about every processed food that you can imagine. Okay, and we'll get into in just a few slides why that is so critical and why that process has been taking place. But in fact, there are, I believe, I should actually double check on that before I say that it's for certain. But there at least at some point was a mandate that foods be fortified with folate in order to ensure that there was an adequate intake within the general population. And again, we'll talk about why that's so important. Food sources typically found in highest quantities within legumes, beans, leafy green vegetables, so avocados, as well as oranges. So folate can be broken down in foods that become available. Fortification is so effective because folate is very bioavailable within foods. So fortifying foods with folate ensures that people are going to get a sufficient amount. There is some storage in the liver, and its major functions are into functioning as a coenzyme for an enzyme called tetrahydrofolic acid, or tetrahydrofolase, and that supports DNA synthesis as well as amino acid metabolism. So being as that B12 is involved in this process, you could understand that, so folate carries out some of this rate limiting step in this process, and so if you have vitamin B12 that gets you to a certain point, it can, and being deficient in that, if you take in folate, you are going to mask that, that deficiency, and that could be pretty detrimental to some of these processes, right? So that wouldn't be so good for your overall health and well-being. Again, much like pyridoxine, folate functions in neurotransmitter synthesis, so that's incredibly important in growing and developing babies especially, but for our general well-being also. And deficiency results in at least one result of deficiency is a condition called megaloblastic anemia, which is essentially destruction of these red blood cells. So again, a lot of these water-soluble vitamins, if you remember back from last week, a good number of them are involved in supporting red blood cell health, and so being deficient in these vitamins can lead to insufficient, dysfunctional, or just destroyed red blood cells, which leads to anemia, and that's a pretty serious consequence. And although we talked about how for most of these vitamins that in some of these conditions, like we talked about beriberi, those are extreme deficiencies that typically aren't seen in advanced countries like the United States. Getting to a deficiency that's results in anemia is a more realistic scenario, something that you can see just from a lack of good quality intake. So from a clinical perspective for you guys, anemia is something that is pretty prevalent in clinical offices, and so understanding what people's nutritional history may provide you guys some really good insight as to how to maybe overcome some of these anemias just through dietary recommendations or supplementing. Okay, so it's really important to not only recognize where these vitamins are important, but then from just a clinical perspective of having this in the back of your mind and knowing how to ask good questions to tease apart where these deficiencies are coming from and how one vitamin, because so many of these vitamins contribute to anemia, being able to identify what vitamins people are potentially deficient in is pretty important, right? But the biggest risk for a folate deficiency is a condition called neural tube defects. And in particular, a disease called spina bifida. So this is really important then for maternal, in regards to maternal status, so pregnancy. Mothers that are deficient in folate not only affect their own health, but affect the development of their children. So all women capable of getting pregnant, so even if women are thinking about starting to try and get pregnant, are urged to take in 400 micrograms of folic acid a day. So that's a pretty significant dose. Current fortification yields about half of that daily. So that's still, I mean, while that's good, that still is only 50%. So you need to, if you're thinking about getting pregnant anyways, or if you are pregnant, making sure that you have other sources like supplementation to get you to that 400 level is really important. And the reason spina bifida is such a huge concern is you can see at the bottom here in this picture of the screen. So this is spina bifida occulta, and essentially what happens is, as we talked about, folic acid is important in the neurologic tissue development. And so this is a picture of your spine if you were looking down from the top of your head to your feet. Okay, so this is the top of a vertebrae. So this is the front. Okay, so this would be the side that faces your stomach. And then the points in the back are what you feel if you reach in your back and you feel the lumps in the middle of your back. Those are your spinous processes. And so what happens when your spine is developing is you get these bodies that develop, and then little branches or pedicles form out from that, and then they close together to form your spinal canal for, again, just like the carpal tunnel, for your spinal cord to travel through. Well, if you have a deficiency in folic acid, that can cause this formation of this canal, or the fusion of those pedicles together to form these spinous processes, to not carry through, and to cause a herniation or a protrusion, a bulging out of the spinal fluid, the spinal canal, out into the skin. And so this is essentially spinal fluid buildup and within this poor infant, and so this is a very, very, very serious disease and serious consequence of folic acid deficiency. So folic acid is incredibly important to maternal mothers in particular. Yeah, I guess it's just my little soapbox from a clinical perspective, because this can be very, very deadly. Essentially, you're leaving spinal cord completely exposed, and it's really painful, as well as dangerous. And there are obviously, because of this, even if you were able to, a child like this, even if this child is able to be surgically repaired, there are long-term neurologic consequences and developmental consequences to these kids. So folic acid, very important. Vitamin B12 or cobalamin. Average intake is about 2 to 3 times the RDA, which is not such a bad thing because there is no upper limit. Plant sources for this vitamin alone are not a sufficient source to obtain an adequate intake of vitamin B12, so that would lead one to believe that naturally food sources that would be high in cobalamin would be animal or seafood products. So vegetarians or vegans often need to supplement their diets with a daily multivitamin in order to obtain this. So it's not to tell somebody or to ward anybody off that may be a vegetarian or vegan that you aren't going to be able to get enough B12. You certainly can through supplementation. It's just something to think about, that if you, again, clinically are seeing people who are showing signs of a B12 deficiency, asking questions about their history and their dietary history can provide you some insight. If they tell you they're vegan or vegetarian, it might be a good indication to ask them whether or not they're taking a daily multivitamin, right? So if you guys remember back to some of the first vitamins we talked about, this metabolic trapping, right? And that some of these vitamins need to be essentially modified while they're absorbed to allow them entry into the intestinal system, and then they are remodified in order to trap that. So just like glucose getting into the cell, we talked about that, right? Glucose gets in and then it's phosphorylated to glucose 6-phosphate, and that keeps it in the cell, right? So vitamin B12 absorption goes through kind of some of these similar processes. So when you obtain vitamin B12 or cobalamin from food sources, it's bound to this R protein. And so once you consume this, the vitamin makes its way into the stomach, where hydrochloric acid and peptin release vitamin B12 bound in food and make it a little bit more bioavailable. So then free B12 binds with this R protein, and then the parietal cells within the stomach secrete intrinsic factor. Within the small intestine, then trypsin forms from the pancreas, releases R protein from vitamin B12, and links vitamin B12 with this intrinsic factor. Within the intestinal system, then, vitamin B12 and intrinsic factor complex is absorbed into the blood and binds to its transport proteins, and it can be stored in some amounts in the liver. Okay, so there's this constant modification of this vitamin B12 to regulate its retention and absorption and transport within the body. So as our next question of the day then, this is a question that I probably got more than any other question nutritionally in my clinical practice. And so I wanted to run this guy by you guys and see what you thought. So is it true that whole food supplements are better than synthetic ones because the body can recognize them better? So on the left here you have an example of a company that produces vitamins from whole food sources. Okay, so they get vitamin C from breaking down oranges. They get cobalamin from from bovine blood or something, and they extract these nutrients from these whole raw food sources, and they package them into a supplement, and then they sell that to people. Whereas something like Centrum may synthetically make vitamin C, vitamin K, whatever, in a lab, and then package that into a vitamin and sell that to you. So the question is, do you guys think that having a supplement from a whole food source, like fruits and vegetables and animal products, is better for you or more easily digested than something that's synthetically derived in a lab? So take your cell phone and text 15491 plus your answer. So you got to type this out. So type in either whole food or type in synthetic to that number, and then we'll take a peek. So I'll give you guys a minute to get that number, or those numbers down, and then we'll look at this.
The standard rates apply to the
I'm not at fault. Okay, let's close this down and see where you guys are at. So we've got 8. Okay, cool. The number, here we go. Good? Okay, I'll leave it open, but let's take a peek here and see what you guys are saying. Okay, so it looks, again, pretty close to our 50-50 trend that we continued from last week, but that's good. So nobody really seems to, well, it looks like there's a little bit more of whole foods. So let's just ask, anybody that answered whole foods want to share with us why they think a whole food supplement is better absorbed, better recognized, better for you than a synthetic one? Too early yet for me to ask you guys? If I offered you a quarter, 50 cents? Still not enough? Okay. Anybody that answered synthetic want to share with us? No? Yeah.
Well, like you said, for some of them, that first they had, if it was a food source, your body had to make it like available.
Sure.
So I don't know, maybe if it was synthetic, you wouldn't have to. I don't know.
that's exactly the right answer, or at least the answer that I come up with. So, yes? Yeah, okay, so the answer was that in some of these vitamins that we talked about, right, I said that they had to be modified before they could be absorbed, and then they had to be remodified. And when you have these vitamins that are accrued from a natural source, that means you have to go through these modification processes in order to absorb them. But this student had suggested that maybe in the processing or creation of some of these synthetic forms, that they may make them already bioavailable. Okay, so maybe they dephosphorylate them, or they break this B12 away from the R protein, so they make it more bioavailable for absorption in your body and utilization, and that's exactly right. But there's a caveat with that, right? So the question that I propose to people was, so there's a couple things you have to keep in mind, all right? So vitamin A from a plant source and vitamin A that's synthetically made, they come from organic compounds, right? Carbon, nitrogen, oxygen, hydrogen, okay? So if you make vitamin A, in order for it to be called vitamin A, it has to look exactly like vitamin A that you would get from a food source. Because if it looked any different, it wouldn't be vitamin A, right? So chemically, structurally, there's no difference, okay? There could be differences in absorption rates because of how they are derived. So synthetically made, they could be, they are vitamin A, but maybe they're made without being bound to cofactors or these modifications that keep these natural sources from being absorbed as efficiently and effectively, okay? But then the third thing you have to keep in mind is that even with those two things being said, to me, the most important thing that you are getting from a vitamin is a good quality vitamin, meaning that you're purchasing a vitamin from a company that follows good manufacturing practices. Because even if the synthetic forms are going to be better for you, or even if the natural forms are going to be better for you, depending on the vitamin and how much is in it, if you are buying from a really crappy supplier that has contaminants and other things that are in these products, that's not going to be so good for you either, right? So you got to make sure that you're getting a good source, that you're getting a reliable source, and that you're getting what you're paying for. So one of the caveats with supplementation, dietary supplementation, including multivitamins, is that they're not regulated directly by the Food and Drug Administration, the FDA, right? So most of the regulation that occurs with dietary supplements, vitamins and minerals, is self-regulation. So when you look at the back of your label of Centrum, let me just see if this will fix by. Okay, so if you look at the back of your label of Centrum, okay, and it tells you that you're getting 3,000% of everything that's in there. First and foremost, you're certainly not going to absorb all 3,000% of that, and in most cases we wouldn't want to do that because we've seen there's consequences to overconsumption, right? But there's also just critical thinking. Just think, if you're buying a bottle of Centrum for, let's just say, $4, and it says that you're getting 3,000% of every vitamin and mineral that they have on there, and their list is like this long, do you really think that they were able to put that much of those vitamins in that big of a quantity into a bottle and sell it to you for $4 and make a profit? Probably not. But that also doesn't mean that if a company that sells you a product, like say this one where they say it's whole food, it's natural, it's great for you, so we sell it for $40 a bottle because you're getting really good sources and we have everything that's in there that we say, and they only have 50%. Well, they still may not be 50% in there. You don't know that. But the nice thing is that there are resources like the NSF and consumer labs that are third-party testers for these dietary supplements that will pull products, or companies can either go to them, or in the instance of consumer labs, they will just go and pull products off of the shelf and then bring them in for testing. So they'll test for toxicity to see if there's contaminants. They'll test for quality. So if the product says that there's 100% of vitamin C, is there really that much vitamin C in the product? And then they'll also do absorption rate tests and breakdown to see whether or not that supplement will break down to allow absorption in a manner in which you would actually get something from it. So is it going to be broken down and then readily digested and absorbed in your body? And those products, you don't see them here because I did not choose products that have them, but they will have a label right on the front that says NSF or says Consumer Lab Verified. And so if that's the case, then you can have a better trust that that product actually has in it what it says is in it, because it's been randomly selected and tested, right? So even if this company goes to NSF and says, hey, we want you to test this bottle right here and tell us what's in it, well, that company could have just made that one bottle really great and had really crappy practices. So NSF says, no, we aren't going to do that. What we will do is if you agree to this and you want our input, we will just show up to your facilities at some day and we will take random samplings from different parts and we will pull those products and we will test them. So there's some randomness to this. So it's not just hey, we're going to pay to have this really cool sticker on the front of our bottle and make people again think that they're getting something good. These are ways to know or to test for reliability.
Jonathan, do they follow up?
They can. I don't know. I don't know how often the NSF will go and test. So one of the caveats to this, right, is that performing all of this testing, it's expensive. And so again, that kind of correlates to the price that you're going to see with some of these things. But the sticker only gives you validation for a given period of time. So if you want to maintain that sticker, then yes, there is going to be retesting. But the company has to pay for that. Okay. Yeah. All right, so let's continue on. Does anybody have any questions? Anything more from that? Does that all make sense to you guys? Give you some good input? Okay. So back to our vitamin B12. It functions in two different enzymatic reactions. One is the formation of methionine from homocysteine, or amino acid metabolism. And that is a coenzyme for methionine synthase. And also needed for oxidation of odd chain fatty acids. Okay, so this right here, remember tetrahydrofolase, the enzyme that folate acts as a coenzyme for. So here is where folate is required, and here is where vitamin B12 is required. And so again, if you have I intakes, because vitamin B12 is catalyzing reactions that results in this, if you're taking in large amounts of folic acid, you're going to have this sufficiency. But if you're deficient in B12, it may mask this. Do you guys see how that, you see that? So this is upstream. So this starts, and so the consequence is the production of this this enzyme that folic acid is required for. So if you have the product, the end result, it could mask another deficiency in a vitamin that is contributing to the production of this. So that's where there's kind of this contention in fortifying all of our foods with folic acid and taking in large amounts, is that it could mask another vitamin deficiency, okay? Okay, so just like most of the other water-soluble vitamins that we've discussed, deficiency can lead to several types of anemia. Vitamin B12 and folate are both also required for myelination, I believe it is, in the nervous system, and so they can lead to deficiencies can lead to nerve degeneration. You can increase homocysteine levels that we talked about in the previous slide. So homocysteine is linked to having increased homocysteine is linked to an increased risk for heart attacks and stroke. So if you have a deficiency, you're not going to be converting that homocysteine into that pathway, and that could lead to buildups, and that's not such a good thing for cardiovascular health. And then there's there's some evidence. It's not necessarily conclusive. They haven't closed the book yet on B12 supplementation in reducing the risk of heart attack or stroke. Okay, so just because you're deficient in it and having homocysteine increased amounts of homocysteine can lead to an increased risk for heart attack or stroke. There, unfortunately, is not what would probably be considered just, I guess, common sense to think that if you're deficient in something and you have an increased risk, that if you take in a sufficient amount, you reduce your risk. So the verdict's still out on that one, I guess. As we mentioned previously, the elderly and vegetarians are most at risk. And toxicity, too much folic acid, as I mentioned earlier, can mask this deficiency, which is not a good thing for anemia risk, right, or homocysteine buildup risk. All right, choline. Choline has an upper limit of 3.5 grams. It can be synthesized in the body a little bit more readily than some of these other vitamins. Food sources that it is rich in include milk, liver, eggs, and peanuts in the form of lecithin. And there are some stored in most tissues. So we said eggs are a good source. Who remembers another vitamin we talked about last week that had a good source from eggs, but there was a protein in the eggs that caused it to not be absorbed so well? Anybody remember? Yep, you got it. You remember the protein? Yep. Good. Cool. So, choline functions as a contributor to phospholipids, cell walls, cell membrane, lipoproteins, so that would be circulating like VLDL, LDL, HDL. Cell membranes, as I said, because of phospholipids, and is also a neurotransmitter precursor. So along with folic acid and B12, choline is also important for neurologic function. And same goes for, we talked about B6, right? So deficiencies in choline are rare because of the food sources, milk, eggs. We get a lot of those in the United States. But an increase or a deficiency in choline may cause an increase in your risk for fatty liver. And this is due to suppressed VLDL synthesis. So we talked about lipoproteins. VLDL is a lipoprotein. So if choline is important for, just one second, I see. If choline is important in the production of some of the proteins that are involved in the synthesis of these lipoproteins, you can imagine then that having a deficiency would mean that you have a buildup of fat in your liver, which is a major trafficking organ for circulating fat. And so if you have a buildup, if you can't secrete that through lipoproteins, you're going to have a buildup of fat in your liver, and that is a pretty detrimental disease, because if you leave fatty liver and you leave it to progress, it causes scarring and inflammation, and that can lead to a disease called cirrhosis. If you've ever heard of cirrhosis, most commonly is associated with alcoholism, but it can be a consequence of non-alcoholic fatty liver disease or fatty liver, and that can lead to liver cancer. So liver failure and liver cancer, so that's not such a good thing. Yes?
How much being an alcoholic versus moderate intake of alcohol affect this?
So that's a great question. So the question was, how much would being an alcoholic versus just moderate alcohol consumption contribute to risk of cirrhosis? Or, okay. So it depends. It depends on your sex, male or female. It depends on your body size. But generally, moderate consumption is typically less than 7 drinks a week. And then that also, you have to consider binge drinking. So if you go out on Monday night and drink 7 drinks and then don't drink the rest of the week, that's not very good for your liver health as well. But moderate consumption, while it has some long-term potential risk because you're still consuming alcohol on a somewhat regular basis, lower moderate consumption has other positive ancillary benefits as well. So alcohol is one of those where it's very contentious. But yeah, when you're talking about alcoholism, you're talking about typically, people that are, they're full-blown alcoholics, so they're consuming, pretty large amounts of alcohol on a regular basis. But having that being said, having 2-3 beers every day is not going to be good for your liver health as well. Okay, especially long term. Any other questions? Okay. Vitamin C, or ascorbic acid. Smokers need an additional 35 milligrams per day due to the oxidative stress that they are exposed to from smoking. The upper limit is 2 grams a day. So even having smokers needing an increased intake, that's still far from the upper limit. Oh, the blue popped up right away. Okay, so many animals can make their own vitamin C, but not human beings. So we need vitamin C from food sources. There is some storage, mostly in the brain and adrenal glands, which sit on top of your kidneys. But again, because they're water soluble, that storage is pretty transient and minimal, so you need good daily consumption. Good tune. So, you need to eat vitamin C, you scurvy dogs, because deficiency leads to scurvy. So does anybody know where scurvy was most prominent and how they came up with using vitamin C or citrus fruits? Wasn't Alaska? Yeah, so the people that were doing these transatlantic, transcontinental trips were becoming very deficient in vitamins, and so they were developing scurvy, and they determined that just giving them, I think it was limes, I think they started with limes, and they were eating limes to obtain their daily source of vitamin C, and it was curing this scurvy. So vitamin C functions within our bodies is a precursor to collagen or connective tissue synthesis. It is an antioxidant, so as we previously mentioned, smokers have oxidative stress from the smoking, and so vitamin C can help to combat that in a what's the word I'm looking for? It escapes me, but protective benefit essentially. So remember we talked last time that not all vitamins in every scenario are the same, and that you can actually increase the risk for certain diseases, like if you were, we talked about cancer in the context of cancer, right? That antioxidants could potentially protect cancer cells because they produce lots of oxidants that could destroy them. So it's an issue you have to be aware of, but from a preventative standpoint, that's the word I was looking for. It's good, right? It's important for iron absorption and a cofactor for some enzymes. So because vitamin C is necessary for the synthesis of collagen, deficiency in the disease scurvy. Scurvy is a disease that results from symptoms of a lack of collagen formation, okay? So you get bleeding in your gums, your skin, etc. So you have really sensitive gums and they can start to bleed. Give me 1 second, okay? And then it's now obviously fairly uncommon, especially in developed countries, but as we talked about with a lot of these water-soluble vitamins, deficiencies in third world countries, developing countries is a little bit more prominent. Some Americans are deficient, but it's subclinical, meaning that it's not enough to like cause scurvy. Interestingly enough, vitamin C, supplemental vitamin C, has little effect on treating the common cold. So there are lots of products that, like Daily C and Airborne, that tout that if they have tons of vitamin C in it to help you combat some of these diseases, and so these infections. And while vitamin C can support being an antioxidant from a preventative standpoint, if your symptoms show up clinically of a cold or flu, taking excess vitamin C is not going to do anything for you in order to get over that illness faster. So maybe don't rely on some of those products as much as maybe some of us do. Yeah, you had a question.
You said that the upper limit is 2 grams. What
Right.
is the side effect of taking too much?
Taking it too much? That's a good question. I think... What? Oh, sorry. So the question was, is there a consequence? So the upper limit was 2 grams. Is there a consequence for going above and beyond that 2 grams per day? I'm not entirely certain. That's a good question. That would be a lot of vitamin C. You'd have to be, I mean, like, chowing those Daily C's like chiclets, and probably eating fruit with every single meal. But I'll look.
I think it can cause nausea, and it's also hard on your kidneys.
Yeah. Yeah. That would probably be what, yeah. So yeah, good question. Any other questions? Okay. So we have our last question of the day. This came from somebody in class that said, when I eat too much kale, sometimes I get an upset stomach, and I was wondering why. Is there something in this, in the food, in kale, that is difficult for the body to break down? So one of the consequences of, or side effects or downfalls of consuming raw kale in particular is that it can cause bloating. So you can get a nice big belly like that, and then you can bump into somebody on the bus. So kale is been touted recently as one of these superfoods, and it certainly is the case. It's packed with lots of insoluble fibers. It's really rich in fiber. It's got good sources of different vitamins and minerals, so it's really great. But consuming raw kale in particular has a couple of different compounds that have been suggested to contribute to some of this digestive distress, okay? One being a sugar called raffinose, or raffinose, I guess I don't know how that's pronounced, but it's a sugar that's present in kale that humans do not have an enzyme or cannot digest and break down, and so it can get into your intestinal system and be fermented by the bacteria that are there, which can lead to flatulence and bloating and kind of gassiness. And then there is large concentrations of vitamin K, and there's another oxalates. So raw kale contains oxalates, and that can cause this bloating or digestive distress as well. But the good news is that if you steam this or cook it, it breaks these compounds down a little bit and makes kale more digestible. But because it's very rich in insoluble fiber, consuming lots of it, even when you cook it, can still cause some of that digestive distress. So I guess my input would be, number one, cook it, and that will help. And then number two, probably just consume smaller quantities of it on a more regular basis, and that should help with the digestibility and some of your digestive issues. Cool? All right, well, thank you guys very much. I hope that you have taken something from these last couple of classes, and if you have any other questions, again, I'm the TA for the class, so you can email me. I'm happy to chat with you about career decisions or career aspirations or anything outside of class as well that I can be of insight to you guys. So thanks, and now Mallory's going to come and talk to you guys.
Okay. Oh, wow. All right. Thank you. Let me just get my slides up quick. Okay. As Jonathan said, my name is Mallory Franklin. I am a PhD candidate in Dr. Mashik's lab, your fearless leader, as well as mine. And I will be guiding you through chapters 14 and 15, which is on water, major minerals, as well as trace minerals. Now, I'm sure that a lot of you are thinking that these are probably going to be the most boring chapters in this entire course. I'm getting a few nods, and I'm hoping I convince you otherwise. I think that you don't grasp the full importance of water and minerals. So water actually makes up 60% of your entire body. So that is over 50%, which means that water is the most abundant molecule in your body. I'm sure you've heard this, but you can survive up to 3 weeks without food. Don't really need it. But without water, you'll only survive about 3 days. Just highlighting its importance. So if I were you guys planning for a zombie apocalypse, I would be packing water into my underground shelter and not so much Doritos or chips or something. But as far as minerals go, when minerals are dissolved in the water in your body, they're called electrolytes. The root word of electrolyte is electric or electricity, and that's exactly what they do. They facilitate the electrical energy in your body. So the nervous impulse from my brain to my arm telling me to pick up this water bottle is through electrolytes. The contraction of my muscle that gives me the energy or the work to lift up this water bottle is also electrolytes. So without water, you wouldn't survive for very long. And without electrolytes, you wouldn't be able to do the mundane tasks that you take for granted every day. So do you guys think water and minerals are important? Yes. Yeah. There you go. Okay. All right, well, let's get started. So water, where are you at? The water in your body is divided into 2 compartments. You have your intracellular water, intracellular fluid, that is the fluid that's in every single one of your cells. Okay, it's in your liver cells, skin cells, kidney cells. You guys get it? And this makes up about 2/3 of your body's water. Now the other compartment is your extracellular fluid. So this is the fluid that is in between your cells, the interstitial fluid. And it also is the fluid that's in your blood and lymph system, so the intravascular fluids, sorry. And as I highlighted before, within this water, there's solute, or electrolytes. So you can have cations that are positively charged, or anions that are negatively charged. So here is just a list of some of the major, did you guys get all that written down? I guess it's only 3 things. Okay. Here's a list of the major electrolytes in your intracellular and extracellular fluids. So you can see that in your intracellular fluid, potassium and magnesium are very important cations, while in your extracellular fluid, the major cations are sodium and calcium. So, yeah.
I heard that sodium can inhibit absorption of calcium.
So we'll get into that a little bit in bioavailability, but sometimes when ions have similar charges or absorbed in the same pathway, they can inhibit their absorption. So here, sodium, is a +1 and calcium is a +2, so I haven't heard that. Where have you heard that?
My doctor, when she said I needed to stop eating as much sodium.
Okay. Well, I think overall people consume too much sodium. That's something you hear all the time, that Americans, our diet is high in processed foods, therefore high in sodium, and we don't get enough potassium. So why is that important? Why is the balance of sodium and potassium so important? Does anybody have any ideas? No? Yeah?
Because that's how your nerves send messages to the body.
Right, so that is very important. That's how your nerves send messages to the rest of your body. But also, if you see, potassium is a major intracellular cation, while sodium is the major extracellular cation. So, as I said before, water is divided into these two compartments. You have it in your extracellular fluid as well as your intracellular fluid. And the electrolytes in these two compartments control the balance of water on either side of a cell membrane. So water can pass through a cell membrane through osmosis. And it goes from an area of low electrolytes to an area of high electrolytes. So if you have, in this picture, if you have a solution, that is hypotonic, okay, indicating hypo, less, you have low sodium in that solution, and you put a cell in there, water is going to flood into the cell because there's a higher concentration of potassium inside the cell. This is going to cause the cell to swell and potentially rupture, and you can get tissue damage and a lot of problems that correlate with this. On the other side, if you have too much sodium, you create a hypertonic solution in your extracellular fluid, and therefore the water in your cell is going to leave and the cell's going to shrink, which is also bad. So your body really wants to be in this isotonic state where you have a nice balance of electrolytes in your cells and outside of your cells, which is why it's important that the amount of sodium you consume is equal to the amount of potassium that you consume. Cool. So your body is really good at regulating the concentration of electrolytes inside and outside your cells, and it does this through a potassium-sodium pump. So this potassium-sodium pump actually transports electrolytes across the concentration gradient. So concentration gradient is the difference in concentration. So you have higher concentration on one side and lower concentration on the other. So to move against it, it's kind of like swimming upstream. You know, you're going to require energy. So this pump requires ATP to be able to move 3 sodium anions into the cell. Into the extracellular fluid, and then 2 potassium ions out of the cell. So this picture shows you that 3 sodium ions can enter this proton pump, and as you cleave ATP, it provides the energy necessary to shuttle them into the extracellular space, while 2 potassium ions can go into the intracellular space. So what does this water do in our bodies? Water is important for the transportation of nutrients and oxygen. So I talked about some of the extracellular fluid being in your intravascular systems, right? Your blood and your lymph. And your blood system is very important for transporting lipid and vitamins and oxygen bound to heme. It's also important for miscellaneous body fluids, so saliva production when you're eating something, or also bile acids when you're digesting food. And it provides lubrication. It acts as a surfactant between your cells. And it's also required in some enzyme reactions that we're not going to dive into, as well as temperature regulation. So when you get hot, your body sweats, and this water, perspiration, cools your body off. But in addition, water actually has a high specific heat, meaning that it's very resistant to temperature change, which is why if you go outside and it's minus 30 out, you are going to take a little bit longer to freeze to death compared to if you were made up of a metal or something that has a lower specific heat. And it's also important for waste removal. So that includes feces or urine. So where do we get water from in our diet? A lot of people think that you can only get water by drinking it. And you always say that we don't drink enough water. You see those people carrying around those giant gallons because they're trying to be healthy. It's a little excessive, if you ask me, because a lot of the water that you get actually comes from foods that you eat as well. So if you have a primarily plant-based diet, there's a lot of water in the plants or the vegetables and fruits that you're eating. So if you look at this picture, you can see, potatoes, lettuce, banana, all of these plant-based sources are high in water. So that means that the water you have to drink during the day is a lot less. But the needs can vary depending on body size. So I keep saying that 60% of you is water, but that can be variable. Adipose tissue actually only contains about 10% water, while muscle is more like 75% water. So if you're a really lean individual and you work out all the time and you have a lot of muscle mass, you actually have a lot more water than someone who is sedentary and maybe has a lot of fat mass on their body. So you have to take that into consideration when you're thinking about your dietary needs for water. And also physical activity. So for one part, the muscle that you have, but also when you're active, you tend to perspire, and that's water that you're losing. Environmental conditions can also impact this. So if it's really hot outside, you're sweating, losing water. And then dietary intake. Like I said before, if you eat a lot of plants, like fruits and vegetables, you're getting a lot more water than someone who eats only processed foods. So overall, males need about 15 cups a day, and females need about 11 cups a day, but that's based on the assumption that 80% of your fluids, or 80% of your water is coming from fluid intake. So how do we get water? I kind of just talked about this. You get water from drinking it. You get water from eating it in fruits and vegetables. But you also get water through respiration. So you guys learned a while back about the electron transport chain, maybe, at least in high school, maybe in this class, and how at the end of it, oxygen is reduced to water. That water produced from metabolism is also a source of water in your body. Water leaves your body through perspiration when you're sweating, also just through exhaling. So you breathe out water, and then through urination and bowel movements. So water can be toxic. You can consume too much water. It's called hyponatremia, which actually means that you have low serum sodium levels. So how this happens is that your kidneys can't filter water as quickly as you are consuming it. So what you're essentially doing is diluting out the sodium in your blood, which is making a hypotonic solution, which means what's going to happen to your cells? They're going to swell, right? You're going to get bigger, and you're going to have problems. And then deficiencies, most of you know, is dehydration. You have muscle cramping, decreased blood pressure. People always say, like, whoa, my urine's bright yellow, I should probably go drink some water. It's a good indicator, too. And you can get headaches, lack of focus, vision, blurry, it's all bad. So the body has two primary responses to deal with this. One is the antidiuretic hormone, which we'll talk through, and the other is the renin-angiotensin and aldosterone system, which is quite the mouthful. So the first one, your antidiuretic hormone. What happens is your brain receives signals that you have increased blood osmolality, which means that you have more a hypertonic solution. And this stimulates the posterior pituitary gland, which is right there. Oh. And this secretes antidiuretic hormone, which then travels to your kidney and is like, hey, kidney, we're not doing so hot. Please retain more water. So your kidney's like, got it. And that's why if you do urinate when you're dehydrated, your urine's really concentrated because your kidney is trying to conserve the water that it would normally be secreting. So by this, you maintain or restore your blood pressure so that your cells stay happy. The other one is a little bit more extensive. The renin, angiotensin, and aldosterone system. So your kidneys can also sense when you have low blood pressure, and they secrete an enzyme called renin. And renin activates angiotensinogen that comes from your liver and makes angiotensin 1. From there, angiotensin 1 becomes angiotensin 2 in your lungs. And then angiotensin 2 actually serves two purposes. One, it actually tells blood vessels to constrict more to increase blood pressure. But it also travels to your adrenal gland, which sits atop your kidney, as Jonathan had mentioned. And your adrenal gland secretes aldosterone. And this aldosterone is a hormone that then goes back to the kidney, full circle, and tells it to retain more sodium and more chloride. And by retaining more electrolytes, you're actually increasing the osmosis back into your body, and because of that, you're retaining more water. So both of these, all in all, tell your kidneys that, hey, we need to spare the water that we have, so don't secrete as much. So this is all that we have about water today. Does anyone have any questions? No. 9:08. Oh, what's up, Jonathan?
When I drink coffee, I have to pee more. Why?
Ooh, that's a very good question. Coffee is a diuretic. And diuretics make you pee more. Do you have anything to elaborate on that?
I think it doesn't. Caffeine suppresses the ADH, right?
Oh, okay. Yeah, so caffeine actually suppresses the antidiuretic hormone that's in your body, so you pee more. So if you are dehydrated, don't drink anything with caffeine in it. It's just going to hurt you even more. I know you're adding fluid, but the caffeine's going to screw that all up. So I think I'm going to stop there before we get into minerals, since we're kind of close to time. So I'll be back on Thursday.